Looking at question 4 tells you that you have a rectangular block of copper metal. Copper can be found on the periodic table. Its element with symbol uppercase C, lowercase u. And this mass of copper metal has 1,896 grams. So this is my mass. Even though the wording in the question says that that's the weight, weight is a less scientific form of saying mass for our purposes right now. So you have the mass given to you in the problem, and then you're also told the dimensions of the block. So you're given the actual measurements, and the measurements they give you are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. So the dimensions that they provided you in this question are actually the length, the width, and the height. So they've given you the volume without directly giving you the value of the volume. You will have to calculate that on your own. So from this data, what is the density of the copper? So I have two different equations written out to you on the side, and these two are going to be helpful for you. I have volume, which is length times width times height. That's just general knowledge from a basic geometry class. And then I have our focus for today, which is density, which is always mass divided by volume. The most common unit that we're going to have for mass is going to be grams. The most common unit that you'll come across for volume can be one of two options. So for volume, we often have milliliters, which we've talked about before, or we can also have centimeter cubed, because 1 milliliter is equal to 1 centimeter cubed. So if you notice the dimensions that we were given in the question, which are 8.4 centimeters, 5.5 centimeters, and 4.6 centimeters, you're going to end up getting cubed units, centimeter cubed units. So that's your volume. So if I go to my original density equation, which is density always equals mass divided by volume, I'm just asked to calculate the density, so I can just straight plug this in. I have 1,896 grams as my mass, and for my volume, I'm going to show each step that needs to be calculated. So I'm going to say 8.4 centimeters by, which means multiply, 5.5 centimeters times 4.6 centimeters. If I were to go to my calculator right now, 1,896, I don't need to do any sort of calculation there, that's just the number. But if I were to multiply my denominator and clear that out, I would get 212.52. I want you to see where the units come from. So if I go back to my numerator for mass, my unit was grams. If I go to my denominator, my unit was centimeter by centimeter by centimeter. So that means centimeter cubed because I multiplied those out. So now look at my remaining units. I have grams in the numerator, centimeter cubed in the denominator. Those are appropriate units for density because it's mass divided by volume. Because neither of those cancel out, you don't have grams over grams, you have grams over centimeter cubed. Both of those units stay for your final answer. So now if I go to my calculator and I get my calculation answer, I should get something like 8.921513269. If your calculator gives you more sig figs, more decimal place values, you're going to have more values after that 9. Based on my data in this question, if I go back and look at what I had provided, I had 1896. So this right there was 4 sig figs. The 8.4, 5.5, and 4.6, each one of those is 2 sig figs. So my final answer needs to be 2 sig figs. So that's the 8 and the 9. Now I need to do my rounding, so the number behind it, the 2 does not bump up the 9, so the rest of this goes away. So my final answer now is 8.9. My units is what's remaining from the question. I had grams in the numerator, centimeter cubed in the denominator. So my unit is grams / centimeter cubed. And just as a reminder, if I were to write it out as 8.9 grams over centimeter cubed, that's an appropriate way to write it out as well. There's no need to either have your division sign for your fraction slanted versus straight. You could do either or. I'm going to continue with this format.